let's construct the next slope field. It also has 25 points. There was a pattern on the previous one that made it much easier to deal with, and it was this. We had vertical lines that all had the same slope. So we can evaluate the slope at any given point. We could have done this 25 times. I have, please don't write this down unless you totally feel like it's necessary. I have written all 25 points out, and we're going to evaluate the slope at all 25 points on the slope field. Most slope fields that you'll deal with have 6, 7, 8, 9 points like that. Okay, we're dealing with dy dx equals negative x over y. So for each of these, we're going to do the opposite of x over y. So negative x over y, that's what we're dealing with. So I'm going to evaluate all these very quickly, actually, and then we'll draw a slope field. You'll see where this is going. So the opposite of x over y, that's 1. The opposite of x over y. The opposite of x over y, so 0 over 2, which is 0. The opposite of x over y, and the opposite of x over y. There we go. We have our first row. I'm going to just go ahead and graph those. When I graph those, I am drawing just a little snippets of slopes, snippet of slopes. So this front row, the top row, is a slope of 1, a slope of a half, a slope of 0, a negative 1/2, and negative 1. So a slope of 1, a slope of about a half, exactly a half, but estimate the way you draw it. 0, negative 1/2, and negative 1. Okay? Here we go. Second row. The opposite of x over y, and that's going to be 2. Now, again, if you're lost about where all this is coming from, I'm plugging in the x and the y here. The opposite of x over y. The opposite of x over y. The opposite of x over y. The opposite, I could have put a negative there just for fun. The opposite of x over y. The opposite of x over y. There we go. Going to keep going. The opposite of x over y. The opposite of x, oops, that'd be positive too. Not that it matters. The opposite of x over y. The opposite of x over y. Something seriously wrong with that. Opposite of x over y. Opposite of x over y. Let's stop right here and assess what's happening. I'm doing some highly illegal things. First of all, you can't equal anything to 0 over 0. Like nothing equals 0 over 0, so that's not a thing. I'm just trying to be mathematically correct in the way I write this. And technically, nothing is going to be this. So really, here's the deal. This one does not exist. This is indeterminate. I think that's worth writing in red. This is a L'Hopital issue if we were finding limits. So this is indeterminate. And from a slope point of view, we would say that this is undefined, and this one's also undefined, and this one's undefined, and this one's undefined, which means these are vertical. Those are vertical lines, and this one should not exist at all. So let's just kind of stop and catch up with what we have. I'm going to do this row, so 2, 1, 0, negative 1, negative 2, a slope of 2, 1, 0, negative 1, negative 2. There we go. And then the next one, which is vertical line, don't do anything, vertical line. Now, there are some online applications that will say don't put a vertical line at all because it's undefined. Really, you don't have to put a vertical line because undefined really means that you can't really draw the slope. But for the sake of where this is going, I am going to do those, and I'll do that, and I'll do that, but not that one. That should be vertical. There we go. All right, let's keep moving. The opposite of x over y. The opposite of x over y. The opposite of x over y. These are going to be 0. That one's going to be 0 also, may as well. The opposite of x over y. The opposite of x over y. And again, you don't have to write all these. This is just me demonstrating what's happening. Going back to the paper, negative 2, negative 1, 0, 1, 2. You're going to love this when it's done. Negative 2, negative 1, 0, 1, 2. And then you kind of see what's happening here. It's kind of circular in its form. It's beautiful. You'll see. You'll see. And the last one is the opposite of x over y. The opposite of x over y, that's equal to negative 1/2. The opposite of x over y, the opposite of x over y, and the opposite of x over y. Okay, 1, oops, negative 1. Negative 1, negative 1 half, 0, 1 half, 1. Negative 1, okay. Negative 1, negative 1 half, 0, 1 half, 1. This should look symmetric, but they don't. Okay, now we're going to finish the actual problem. It says solve the differential equation for C. We're going to take this and we're going to do this thing called separation of variables, and it's where we separate our variables. And we did the same thing up here, didn't really go into too much detail. But we have this beautiful slope field that if we follow the trend around it, like this one, we would actually be following the trend kind of around it. This is going to be circular. I hate to give too much away, but this is what's about to happen. We're going to bring this y up, so we're going to have y dy. It's like cross multiplying. We'll put the negative with the x. And that's equal to negative x, and then the dx is going to come up here. Okay, whatever you do to one side, you do to the other. We are going to integrate this and get rid of all these derivatives. So the notation looks a little wacky. We can just squeeze the integral in there, it works. And we'll have, well, the integral of y would be y squared, 1 half y squared. And the integral of x would be 1 half x squared, but it is negative. And we'll put the c on either side. I like to put it on the right side. That's generally where it goes. But it said solve the differential equation for c. So we're going to bring this 1 half over. 1 half x squared plus 1 half y squared equals c. And we're going to do something that's going to drive you nuts because you're thinking of the way that we have to balance things, but we're going to do it anyway. Here goes. Work with me here. I'm going to get rid of these 1 halves because I really want you to see what this equation is. And I think you already noticed that it is a circle. I've kind of already said it. But if I doubled everything, I would have x squared plus y squared equals, okay, I'm doubling everything, and so you're like, oh, it's 2c. I hear you. You can put that. However, c is, in this context, for these purposes, c is simply a constant, and it will absorb whatever you throw at it. So if you want to double a constant, you still get a constant, okay? This is a circle. This is a circle. So if c equaled 1 at this step, not from the beginning, but at this step, if c equaled 1, then we would have a circle with a radius of 1. If c equaled 4, actually, not 2, we would have a circle with a radius of 2. And so this is the generalized form of this differential equation, and just as this equation will be graphed by following the trend line, so would this. Like for any given c value, like if c equaled 1, we draw it up here. Well, if c equals 1, we draw a circle with a radius of 1. If c equaled 9, the square root of 9 would be 3, we draw a circle with a radius of 3. That's what we're dealing with.